from 2002, here it's the Mechanics 3 question, again from the 2002 exam. And so a pre-response demo that deals with energy and work. And so this was a common type of question for a time on the AP exam, so who knows when it's going to come back, but it does have where you have to design a lab procedure in it. My printing got a little messed up here, but it says an object of mass 0.5 kilograms experiences a force that is associated with the potential energy function U of x equals 4.0 divided by 2.0 plus x, where U is in joules and x is in meters. And so first you have to graph the function. And so I actually just plotted out points for this and then drew my curve of best fit. And you had to have, for full credit, you had to have something that was concave up. You had to have your final point of x equals 5 between 0.5 and 0.75 for the value. So obviously that falls into that here. Then for part B, you need to determine the force associated with the potential energy function as given. And so force is the negative derivative of potential energy with respect to x. So then I'm going to take this. Now, if I'm looking at just this function down below, taking that derivative, you can see then it ends up negative. So the negative here cancels out, and so you end up with this function as your force. For C, you're supposed to find the speed of the particle at x equals 2 meters. So I did conservation of energy here. And there needs to be some statement of conservation of energy. You can't just plug into 1/2 mv squared. And you could use the work kinetic energy theorem. I did energy, and I wanted to show you how you can use an energy diagram to solve this. So when we're at x equals 0, and we have all potential energy, we have 2 joules of potential energy. And when we're at x equals 2, we had 1 joule of potential energy, and I calculated that in part A. And then we know we've got a kinetic energy gained here of 1/2 mv squared. There's no non-conservative forces stated, so we have no work, so nothing's changing. So I can now set the initial and final sides equal to each other, and you can see how easy it is then to solve for my velocity, which is 2 meters per second. Then for part D and E, D asks you to select equipment that you need to verify your calculation in part C. And this time you have a glider on an air track. You could have done this a few different ways. Some things to note. Typically, you're not supposed to check all of the boxes. They don't want you selecting all the equipment. There's sometimes where you can, though. You have to check more than one. Now, if you had done it with photo gates and said you needed 2 photo gates, they consider that more than one, so that would be legitimate. Here, I did a spring and a meter stick, and I said that you need to set it up so that the spring and the glider collide when x equals 2. The glider is going to compress the spring, and you need to then measure the maximum compression of the spring with the meter stick, and then you can solve for velocity using conservation of energy. And I noted at the end that the spring must have a known spring constant. It doesn't have to be long and drawn out, but you should say how each piece of equipment is used. So that's an example of a work energy per response question.